Recently, a discovery has captivated both scientists and space enthusiasts. Bill Nye, the well-known science communicator, made headlines when he revealed that Voyager 1 had detected 300 massive objects in space. The announcement sparked curiosity and raised profound questions. What are these objects? Where did they come from? And what do they mean for our understanding of the universe? For nearly 5 decades, the Voyager missions have been humanity's farthest-reaching messengers. Launched in the summer of 1977, just weeks apart, Voyager 1 and Voyager 2 began their journey with a clear purpose: to study Jupiter and Saturn in detail. Their success was immediate and historic, with Voyager 2 going even further, providing the first-ever close-up images of Uranus in 1986 and Neptune in 1989. These encounters became known as the Voyager Grand Tour. The missions were originally intended to last only 5 years, but Michael Minovich's groundbreaking idea, using a planet's velocity to slingshot a spacecraft farther into the solar system, had set the Voyagers on a path that would carry them far beyond their original destinations. Instead of ending after visiting the outer planets, they pushed on toward the edge of the solar system, and eventually, into deep space. In 2013, NASA made a historic announcement. Voyager 1 had crossed into interstellar space, the region beyond the Sun's magnetic influence. It was as if the spacecraft had stepped out of the busy, protective streets of our solar system and into a quiet, star-filled wilderness. In 2018, Voyager 2 followed, becoming only the second spacecraft to achieve this milestone. Together, they began studying the heliosphere, the invisible bubble formed by the solar wind that shields our system from much of the galaxy's high-energy radiation. At its outer edge lies the heliopause, the shifting, irregular boundary where the Sun's influence fades and interstellar space begins. Voyager 1 and Voyager 2 became our eyes and ears at this boundary, sending back data that revealed a harsher, more energetic environment beyond, where cosmic rays are several times more intense than inside the heliosphere. In 2023, Voyager 1 detected something unexpected, a faint, low-humming sound. It corresponded to vibrations in sparse interstellar gas drifting between the stars. Nicola Fox, head of NASA's Heliophysics Division, emphasized the significance of this discovery, noting that over 46 years, the Voyagers had transformed our understanding of the Sun and its interaction with the galaxy in ways no other spacecraft could. But these achievements are all the more remarkable given the Voyager's power limitations. Each is powered by a radioisotope thermoelectric generator fueled by decaying plutonium. Over time, the decay produces less heat, reducing the available electrical power. To preserve critical functions, NASA has been forced to shut down non-essential systems, even heaters that keep instruments warm in the freezing cold of space. Yet somehow, all 5 key instruments have continued to operate since 2019, baffling scientists who expected them to fail long ago in such extreme cold. The heliopause itself has also defied expectations. It isn't static. It shifts and changes shape, sometimes forming unusual angles. Over the past decade, observations from the Voyagers and NASA's Interstellar Boundary Explorer, IBEX, have revealed significant movements in this boundary. In 2014, IBEX recorded a sudden brightening of energetic particles, hinting at irregularities that didn't fit existing models, an unexpected twist in what had been thought to be a relatively stable structure. These shifts may even explain why Voyager 1 entered interstellar space in 2012 while Voyager 2 crossed 6 years later. Such anomalies have fueled debate among scientists, with some suggesting that our understanding of the heliopause's behavior is far from complete. NASA hopes to answer more questions with the upcoming Interstellar Mapping and Acceleration Probe, IMAP, scheduled for launch in 2025. Meanwhile, the mysteries keep coming. In May 2023, Voyager 1 experienced a strange malfunction in its Attitude Articulation and Control System, AACS, the system that keeps its high-gain antenna pointed precisely toward Earth. The data being sent back suddenly became confused and seemingly random, as if the spacecraft had developed a kind of electronic aphasia. Yet the radio signal itself remained strong, and the antenna was still aimed correctly. The spacecraft's science instruments carried on as though nothing was wrong, leaving engineers with no clear explanation for the AACS anomaly. Even when Voyager 1's fault protection system, designed to put the spacecraft into safe mode if anything went wrong, didn't activate, NASA quickly pinpointed the cause of its odd behavior. The AACS had been routing its signals through an old, long inactive computer. The fix was surprisingly simple. They sent commands to switch data transmission back to a functioning system. Still, no one could say exactly why the AACS made that switch in the first place. The leading theory was that an incorrect instruction from another onboard system had triggered the glitch. It wasn't a danger to Voyager 1, but NASA is determined to prevent a repeat of the problem. By now, Voyager 1 has been traveling through interstellar space for more than 10 years, far beyond the Sun's magnetic shield. That shield acts much like Earth's magnetic field, helping protect spacecraft from cosmic rays and high-energy radiation. Without it, the risk from these particles is much higher. Just like electronics on Earth, Voyager's computers are vulnerable to tiny memory errors caused by radiation strikes, and over decades those errors can accumulate. Susan Dodd, project manager for both Voyager 1 and Voyager 2, notes that such glitches are expected at this stage. These spacecraft were built for a mission of only a few years, and yet they've endured nearly 5 decades in the harshest conditions any probe has faced. It's hard to overstate the feat. These explorers are still running on 1970s-era computers with just 70 kilobytes of memory, less than a digital watch today. Every update NASA sends has to cross billions of miles, making mission control feel like the ultimate long-distance IT help desk. Yet, somehow, both Voyagers keep working, continuing to push into uncharted space. Each probe is roughly the size of a small car, their cameras and instruments a relic of a very different technological era. And yet, they've transformed our view of the solar system. We learned Jupiter is a restless giant with massive storms, glowing polar auroras, and faint, complex rains. Saturn's rains, once thought to be simple, turned out to be braided and intricate, numbering in the thousands. Voyager 1 spotted active volcanoes on Jupiter's moon Io, while Voyager 2 witnessed nitrogen geysers erupting from Neptune's moon Triton in near absolute zero cold. Even more tantalizing, they revealed evidence of vast underground oceans on Europa and Enceladus, potential homes for alien life. Perhaps their most poetic achievement came in 1990 when, at Carl Sagan's suggestion, Voyager 1 turned its camera homeward for the famous pale blue dot image, a tiny speck of Earth suspended in the darkness, captured from over 4 billion miles away. That picture became a humbling reminder of our fragility in the vastness of space. In 2012, Voyager 1 crossed into the interstellar medium, followed by Voyager 2 in 2018. Now so far from home that it takes nearly a full day for their signals to reach Earth, the probes are still adding 3 to 4 light-seconds of distance every single day. NASA's Deep Space Network listens to their faint signals, tiny whispers amid the radio noise of Earth, and pulls back data about a region no spacecraft had ever visited before. The entire mission was made possible by a rare planetary alignment discovered in the 1960s. Using gravitational assists from multiple worlds, a spacecraft could reach Neptune in just 12 years instead of 30. Budget limits forced NASA to scale back the full, grand tour that had been planned, but the Voyagers still went further than anyone could have imagined. Nearly half a century later, they are humanity's farthest and most enduring explorers, carrying our curiosity into the deep beyond. Their story is a reminder that even the simplest technology, when built with care and purpose, can change our understanding of the universe, and keep exploring